Alright, so I thought I'd make a little video here today. I know I haven't made one in a while, job and everything. Can't make one every day necessarily. So I've done some bad art here of maybe a little landscape. You got some grass, some messed up areas, sort of dark city here, and a little light city. A little go button that doesn't do anything yet. But what we're going to learn about today is how I did this. So you can see when I deselect them, the go button goes off, and it knows sort of as I click which tile I'm clicking on. So that's pretty cool, right? And I'm gonna show you how I did that today. It's actually not complex at all. Once you sort of have the math formula for it, it becomes just a matter of you fine-tuning it so that no matter where you press these tiles, you sort of get the desired result, right? And there are some numbers that you can fine-tune for that I'll show you. Anyways, cool. So let's do it. Also, this art was made by me. That's why it looks bad. It's just some like really small art. I think it's like 32 by 16, or maybe it's 16 by 8. My camera is way zoomed in here. Anyways, I have like a standard Libgdx project. You can ignore the number of classes and files I have over here. This is like going to be part of a larger game that I'm getting set up for. And as we know, when you make a Libgdx project, you kind of get a couple things. This is where your game kicks off from, and this is all I have on that screen. So it's very simple. It just extends game, and basically you make a screen, which we'll look at in just a second, and then you set the screen. That's one of as you've seen in like any Libgdx video, this is just sort of this game thing here that this class is extending basically just delegates to screens, and that's how Libgdx works, right? If you want to know a little bit more about screens, just look it up. It's not a complicated concept, but basically when you have a screen, you're going to make it extend screen adapter, and then the game, it'll have this render method, which is basically your game loop, and from the main game class here, you can just say, okay, go to that screen, and you can switch between screens, which is pretty cool. I only have one screen that has multiple scenes though, and that scene is of my creation. The other standard Libgdx class you get is this desktop launcher thing, and this is where your main lives. And all I've done here is set the width and height. In my case, I've set it to 1280 by 720. And then you just make a new sort of application there, which this is already done for you when you load up this file, so you don't have to worry about what this means. It's just a lightweight Java gaming library application. Cool, so let's get right into how I accomplished what I accomplished. So that's the basic stuff. In the main game screen, there's really nothing going on. I've set some static variables, and then I've made this world map scene, and I've basically just go ahead and say, update the world map scene and render it. So the magic really happens in this world map scene class, as we're going to see in just a moment. Now I've done some standard Libgdx stuff in here. I've made a camera. I've set that camera up. You can copy my sort of setup here if you want, though working with Libgdx's camera is not really hard in general, so I'm not sure I need to explain it. You could probably just look all of this stuff up in like 10 minutes. Really, Libgdx's camera is very easy to use, and of course we're using an orthographic camera because it's a 2D game here. Now, some of this other stuff in here is not super important to the video, but we'll talk about it anyways. All this texture region thing is, basically I've loaded all of the textures I have for the game in this sprite sheet up here. I've loaded them all into one texture, which is the sprite sheet. And essentially what this method does that I've created, it gets me all the texture, all the regions out of that texture that I need for this particular scene, which is the world map scene. So let's look at the sprite sheet real quick so you can understand what I did. Basically, it's going to take out the grass tile, the messed up tile, the city tiles here. And I know y'all can't really see what's going on with that because it's so small, but it's not important. The point is it takes what it needs out of this very large texture, and then for my world map scene, all I get is what I need. And then as you see down here, we're using those texture regions to decide what tiles we want, right? The world map tiles are basically just what you see here. They're just textures being drawn to the screen. and I've taken out of this texture regions thing, I've said like, okay, well, at position 0, 0, go ahead and draw me the grass texture or whatever, or the city texture, sorry, this is position 0, 0. And this other one that I have is actually the highlight color. But I don't want to focus too much on this because this isn't really the important part of the video. I want this video to be about, and we've seen this math before, by the way, this is just setting the isometric tiles into position. You've kind of seen me do similar stuff to this before, and I don't really want this to be the focus of the video. What I want the focus of the video to be is how do you know what tile you've clicked, right? That's really what I want the focus of the video to be, is when I click here, how does that that mouse position correlate to this tile? And that's what I'm gonna show you just here in a minute. So once you've got your tiles set up, you know, with the correct texture that you want to draw to the screen and the correct position using the math there, how do you detect that you've clicked on those tiles? All right, cool. And that's what I'm going to show you up here. So you can use this method if gdx.input.isTouched, so just touched. So basically this is going to detect when the mouse has clicked. And we're using just touched here because we don't want it to detect if the mouse is being held down. All we want is, was it clicked? Was it just touched? And if you're making a mobile game, you can also use this just touched for literally have they touched the screen, right? So once the user has clicked, we want to know, have they clicked one of our tiles, right? So the first thing you have to do is you're going to get the mouse position, and that's extremely easy in Libgdx. You're going to just say gdx.input.getx.getY. You've now gotten the x and y position of the mouse. It's that easy. You don't need to worry about how it gets that. Libgdx does that for you. You already know the sort of screen position of your mouse. Now, Libgdx also does something else great for you. It will take those screen coordinates and it will turn them into world coordinates for you. So when I click on the screen here, it's saying like, okay, his screen coordinates are right there on the overall screen. But there's this world that, you know, the camera is only seeing part of, and this world has coordinates too, right? It has a 0, 0 somewhere and a 100, 0 and a 200, 100 or whatever, it has a lot of coordinates. In any case, so how do I know where that mouse is in world space? Well, Libgdx has already handled that for you. So all you have to do is take your camera, your orthographic camera, and say unproject this vector 3 mouse position. And it has to be a vector 3. I'm like 99% certain. Yeah, I'm pretty certain it has to be a vector 3, even though you're technically not using the Z because it's 2D, because I think you could probably use this for a 3D game too. Now, and by the way, you don't have to do something like this where you say, you don't have to do this because, or where you, I'm spelling this wrong, but because this vector 3 is an object, and when you pass it in, Java is automatically passing it by reference for you, and it'll change inside. So you don't actually have to, this does return the vector 3, but you don't actually have to catch that vector 3 because the mouse pause would be changed regardless. Sorry, I'm being very verbose, but basically now you have your mouse position in world space. We're already that far along in this process. All you have to do at this point is determine if those world space coordinates match up with the world space coordinates or of any of your isometric tiles. And this simple math is how we're going to do this. Now, this math is has been derived, hilariously enough, actually from this math up here. Now, I am not going to explain this in this video. If anybody is really interested, there's a website I know of that explains it quite well, and I might put the link to that website down in the description of the video if anyone wants to go and read about it. But I am bad at explaining math concepts. If any of you have watched my other videos, you've probably realized that. So I'm not going to explain this math concept. I'm just going to give you the code. If you'd like to use it, then you can. Now, the only caveat with this code is these numbers over here, the 0.45 and the 0.6. Now, this is where the tuning comes in. So basically, this code here is going to give you your map x and map y with decimal points, and you have to knock off the decimal. What does that mean? So when you click here, let's go through the process. When you click here, your mouse has a screen position. It's then going to be converted into an overall world position. And then you're going to take that world position and you're going to convert it using your tile width and tile height, which, with isometric games, you're going to have to, decide these things. You're going to have to decide what your tile width and height are. I've made mine into static variables. And then it's going to give you the map position. So in this case, this is going to equal out to be 0, 0, I think. Anyways, I'm pretty sure this tile is 0, 0. But anyways, the point is, so at the end of this math, you're going to get depending on where you click in the tile, you're going to get 0.295 or, 0.4567 or some weird decimal number, which is why you have to just cast it to an int and knock off the decimal. That's what I do anyways. Now, there is a little bit of error in this, though. And the error comes in with the spacing of your tiles. So here, I actually have my tiles spaced apart a little bit. But if they were perfectly jammed together, these numbers would have to change, because suddenly, if the tile moved and I kept those numbers the same, I would click here and the tile might not highlight, because suddenly it expects the tile to be here, but actually it's here because I've moved it over, right? So this might take a little bit of playing around on y'all's part, depending on your tile size, because it might change a little bit with tile size too. My tile width is 32, my tile height is 17 currently. That's what I've found I like in terms of the tiles fitting together nicely and stuff. So y'all might need to play around with these numbers a little bit, but this will get you the map position. You can see what I've done here is I've said okay, now that we have the map position, we're going to go ahead and find the tile that has that map position. You can see in my world map tiles, I am tracking the row and the column, which is their tile map position. So 0, 0, 1, 1, 2, 2, etc. And then once I'm just setting it to selected true, and then otherwise deselected. We don't want two selected at a time. So if another one currently is selected, and it's not the tile we're selecting this time, then go ahead and deselect it. And this is for the go button to determine whether a tile is selected or not. And that's it, really. Other than that, you just draw your tiles to the screen. In my case, I've said if the tile is selected, draw its highlighted texture instead of its regular texture. Same thing with the go button. This code isn't beautiful or anything, but it's something I threw together the other day. I think this is pretty straightforward. There probably isn't a need for a long video on this. If y'all want to look at my world map tile class, it's really simple. All I'm doing here is I have the two texture regions that come from my main sprite sheet, which is the regular texture and the highlight texture. I haven't used this yet. There's the is selected Boolean. There's their render position and their tile position, because obviously in this world it has a tile position, but then it also has a render position. So remember, even when you have an isometric tile, it's still a square image, right? Because images are square on computers. That's just the way things work. You don't have a diamond image on a computer, so it's not going to render from here to here. It's going to render from here. It's just this part is transparent. that's why isometric math gets a little bit, or isometric tiles get a little bit tricky. In any case, yeah, so you have a render position somewhere over here in the bottom left corner of this image, and then you have a tile position. And this math right here is gonna take care of whether you've got it in the actual tile, right? So that's good stuff. Cool. So you can see I still need to play with my numbers a little bit. It looks like I have a little bit too much play on the left side, maybe. It's pretty exact in most of the spots. Maybe there's like a little too much play down here. It looks like there might be. You know what though? I'm gonna let you guys figure this out a little bit, and I'm gonna put that article in the description, and y'all can go read that and have fun with it. Otherwise, this video is pretty much done. It's just a quick one to show y'all what I've been working on, some cool stuff. I'm going to be working on a broader isometric project. Hopefully I can get some cool stuff done, like I said. And I'm sure y'all know when you have a job or whatever, it just eats your time a little bit. You don't want to always be programming all the time on your free time. So catch you guys later. Hope you like this one.